Today we're going to discuss handguiding. First prerequisite is to go into the StationSetup.cat file, and under the Software tab, make sure you have the handguiding support option package selected. Once you do that, you want to go to the manual guidance support and change enable maintenance guidance and automatic to false, which will only allow handguiding to be done when you write it in your application. Then you'll see under the KUKA PSMs a few different options of AMFs. First is handguiding device active and then handguiding device inactive. Under the inactive tab, you can select parameters. For example, changing the enabling switch 1 to true. Default is enabling switch media flange touch, which is on the flange of a robot. It's like a button. Some robots don't have that, so you can select other inputs. This input SIB safety 1 is actually on the controller, and it's an interface that you can connect to. You will need a double pole single throw switch in order to use this safety button. You also can go to the station setup and make sure you have the human-robot collaboration selected, which will give you additional options inside of your safety for setting up different tasks. When you go ahead and program the handguiding, there's a few different ways to do this. So once you've done that initial setup with the station setup as well as the safety, you can now go to robot.move, look at the HRC motions object, and select the handguiding static method. This is the easiest way to write a quick test to make sure that your handguiding is working with your hardware. Another option is to create an instance of handguiding motion. You'll have to import the API from the KUKA library by just right-clicking like I did. And then you have a bunch of options to parameterize this object. For example, setting the joint limit max. Here we're going to just go ahead and set all of the maxes to 100. You'll need to use the math library in order to change everything to radians, as that's its expected input. Once we've done that, we'll want to also do the same thing for the mins. So I'm just going to copy and paste this and make all of these negative 100s. The parameters that are available for handguidings are numerous, so make sure that you check out by just Control space after the handguiding option to see all of the options. So we're also going to show you two other options. For example, the velocity limit. So this is setting the joint speed in radians per second. And then again, we're going to do the same thing with Cartesian, which is set Cartesian velocity limit. And as you can see, I'm going to go back to the joint velocity limit and put it to 3, as 100 radians per second is really quick. So Cartesian is millimeters per second. You only want to use one of those, but I just wanted to showcase that you could do a few different things. So let's create a quick method in order to do some testing. Of course, you can just write it in your run, but I like to separate it out for testing purposes. So we're going to create a integer ret that will return what the response is from a dialog box. That can be done using the application UI object. We're going to display a question and we're going to say options. And our options are going to be some sort of parameterized handguiding, some sort of default handguiding, and then an exit. So we're going to do a switch case statement here, and we're just going to run through these different options. Now, when you're programming this, again, make sure to look at what type of motion you're trying to do, whether you're trying to do a move or move async. For this case, the code will stop until the button is actually pressed and released. The press will actually allow the motion to execute, and then the release will cancel the motion and move on through the application. While an async motion will do a very similar thing, except it throws the motion to the motion planner and then continues running with code. So for this architecture purpose of our application, we're just going to do the move. And here we're just robot.move are different types of handguiding options, whether it's the static method or the parameterized object that we created. I'm going to use some loggers just to show you that it is writing, and that is about it.